and we're not going to do that.
Another potential hazard is the possibility of gas from the cutting torch accumulating in pockets of the debris.
Prior to making a main cut, he will drill these areas that may cause gas to accumulate. Once he starts cutting, gases will pass through confined spaces and be vented out these holes that he's drilled. If he didn't do that, what could occur is an underwater explosion. It could rupture eardrums. It's not a good place.
Today, the crew's efforts are concentrated on freeing one of the rig's legs from the mud of the seabed.
It's been difficult removing the leg sections and the spud cans. That's probably been the most difficult effort that we faced through the whole salvage operation.
The diver is cutting through the jack-up teeth on a leg. The steel is 5 inches thick. Working at depths to over 300 feet makes the diver's work even more laborious and time-consuming.
They have to continually check their cut in between burning rods to make sure they're still in the same location, and they're continuing to gain a little metal fatigue every time they burn a rod out of there.
Since Hurricanes Katrina and Rita, Bisso Marine has been constantly salvaging throughout the Gulf. It will take 5 months on this one Rowan rig to recover and reef a derrick, a drill floor, a section of hull, and 3 of the 15 legs and spud cans.
They were 140 some odd feet long, so by the time we stood it up and pulled it up out of the mud, we were lifting up about a 14-story tall building.
After the leg is pulled free, the crane will raise it from the wreck site. But the leg will remain suspended below the surface as it is being towed to the reefing site 90 miles away. After all pieces of the rig have been removed and towed away, the salvage site must be combed of debris with a device called a gorilla net,
which is a large shrimping net with wire through the braided ropes for strength, and they literally drag the site and remove all associated debris within this 1/4 mile radius.
Removing a platform and bringing it ashore is enormously expensive and can cost more than the value of the structure's refurbishing or even its recycled steel. In recognition of the savings to the owner by allowing them to reef the rig, states require a donation from the rig owner equal to half of what removing and scrapping would have cost.
The benefits to the state are obvious. They not only receive the material for the artificial reef program, they also receive funding to continue maintenance of that program. The cost to industry varies, but in general terms, you're looking at $100,000 to $200,000 for the smaller platforms, or in the case of special artificial reef sites, as much as $5 to $6 million donation to the state's particular program.
Although Gulf Coast states have embraced the Rigs to Reefs program, California hasn't. Until it does, it's likely that when Gale and other platforms are decommissioned, they'll be towed ashore and scrapped. But on the Gulf Coast, some entrepreneurs are pursuing a new alternative to scrapping and reefing, one that utilizes their robust design to harvest energy. To create new energy opportunities, a Louisiana company is taking advantage of 2 resources the region has more than enough of: Gulf winds and offshore boneyards. Based in New Iberia, Wind Energy Systems Technology, Inc., or WEST, is designing and creating the technology to convert idle offshore oil and gas platforms into platforms for wind turbines. By combining innovative turbine designs with existing petroleum production technology, they plan to be harvesting renewable energy from offshore wind farms in 2008. Harold Scheffler, the owner of a Cadillac dealership in Lafayette and a co-founder of West, got the idea after a conversation with a Cadillac buyer in the offshore oil business.
A customer was griping about the high cost of taking all this equipment out when they were through with it. And it was a horrendous expense. And I made the comment, if you guys knew you were in the energy business instead of the oil business, when you were through with producing oil on those platforms, you'd put wind turbines on them and have them operational for the next 100 years. And he laughed and said one of those things wouldn't produce enough power to charge a 12-volt battery on the shore.
Determined to prove his customer wrong, Scheffler sought the advice of a friend with vast experience in the industry, Herman Schellstedt.
We did a basic study of that and found that the platforms were way adequate to do this.
He was elated. He was saying, wow, what a wonderful thing to do. It could take all our knowledge of 50, 60 years of putting structures out in the Gulf and apply it to a new renewable form of energy. It would keep Louisiana and all the ports and facilities in the energy business, and it would give us some hope for the future.
A recent survey by Stanford University studied 1,800 sites across the U.S. for prospective wind power generation. From this, they learned that a potential bonanza of energy existed right off the coast of Louisiana and Texas.
They ranked it from 0 to 7, with 7 being a premier site. There were only 23 Category 7 sites, and 6 of those are here in the Gulf from the mouth of the Mississippi to the Sabine River. So we sit here in a premier area in terms of wind.
Scheffler and Schellstedt also went to Europe to study offshore wind farms there.
Germany has power for 22 million homes, 10% of their power. Within 5 or 6 years, we could be as much as 10% of the power if we chose to do that. We think offshore wind can play a major role in that issue. You know, it's a no-brainer. It's free, the fuel is free.
They returned satisfied that Gulf Coast offshore jackets and platforms are built much stronger than European windmill bases, far more able to withstand the stresses of both wave action and turbine vibration.
We think the technology of using a jacket that's placed on the bottom and then pilings are pushed through the legs of the jacket, that's the typical structure that's here in the Gulf, will be a much stronger platform. And we have platforms here that's been out there 50 years through many storms and hurricanes, and they're just as level as the day they were put out here.
By combining state-of-the-art wind turbine technologies with the expertise and experience that virtually wrote the book on offshore oil production, Scheffler and Schellstedt see a bright future for offshore wind farms. There are over 4,000 platforms in the Gulf of Mexico. Scheffler and Schellstedt estimate that approximately 1,000 of them can be used for wind farms. Though they first attempted to build in state waters off Louisiana, their first wind farm will be off Galveston, Texas.
Texas has the infrastructure to sell the power, to receive it into the grid, to allow for renewable energy credits. Before placing their wind turbines, they must first complete research on wind patterns and routes of migratory birds. This study is underway with the aid of a meteorological tower they've erected on a platform on the Galveston site. If the study concludes the site is appropriate, a new topside will be installed to support the first of their wind turbines.
We also have a new design that is a marriage between the wind industry and the oil industry. Our new designs have 3 major features, one of which is a vibration isolator to take the vibration out of the platform. The next is a retractable leg where the actual center member is retracted down to the water level. And third, we have folding blades so we can prepare our wind farm to withstand a direct hit from a hurricane.
If we go with 2.5 megawatt units or 3 megawatt units, which we're leaning towards, propeller size will be 155 feet. 310 feet is the diameter of the whole unit. The hub height is 280 feet.
The power from the individual platforms will be sent to a platform that serves as a gathering station, which would regulate the power and send it to shore through an armored underground cable. The work of converting the platforms will be done at local fabrication facilities, providing jobs and bolstering the local economy, transforming offshore boneyards built for pumping oil into wind energy generators.
We'll go to the scrapyard and take the steel platforms that are coming from offshore. We may get a platform that's out there in 600 feet of water. And out of that one platform, we could make many platforms to go in this water that's 10 feet, just by cutting it and redesigning the top and turn them to a viable platform for offshore wind.
Herman and Harold continue to explore ways to establish wind farms in Louisiana's waters. One of the sites they're most interested in is the Rabbit Island field.
What we're looking at is concrete platforms which are no longer built. They were generally in very shallow water, generally in state waters. One of the major power companies in Louisiana is looking at putting a system here.
Unlike steel, concrete platforms cannot be taken ashore to be scrapped and recycled. If a wind farm is developed here, it would convert an abandoned concrete boneyard into yet another energy source for the state of Louisiana. In recent years, as idle offshore oil and gas platforms are decommissioned and removed, there has been a unique variety of proposals for alternate uses, some of which have already become reality. The same boneyards where platforms and drilling rigs are being refurbished or scrapped are hard at work converting them to offshore laboratories, radar stations, and diving resorts, even as a base station for an elevator to the stars. It may sound like science fiction, but according to a growing number of scientists and engineers, converted oil platforms could be deployed as a critical component in a new space program unlike any other previously attempted. In this technology, payloads and people would be transported to Earth orbit and beyond by riding an elevator to an orbiting satellite along a tether attached to an Earth station on a converted offshore platform.
The space elevator, in simplest terms, has a ribbon with one end attached to Earth, the other end up in space, and it can be ascended by mechanical climbers. It's access to space without rockets.
The end of the ribbon attached to the Earth would be anchored to a converted oil platform. With a deck tied to steel pilings driven deep into the seabed, this versatile design would serve as the base station for operating the space elevator. Space travel experts, including NASA scientists, assure us that the dynamics are simple, straightforward, and could work.
To deploy the space elevator, you launch a satellite up into orbit, it deploys down a ribbon, you grab that ribbon at Earth, and we send climbers up that ribbon to make it larger, and that builds up the full space elevator.
Gravity would pull the ribbon connecting the space station and the former oil platform straight, in much the same way that a string attached to a ball would stay straight if you swung it around.
The ribbon is 62,000 miles long, and the only reason that keeps it from breaking is that we're going to be using the strongest material that's ever been made. It's called carbon nanotubes. It's a tubular shape arrangement of carbon, very similar to graphite, and it's pound for pound several hundred times stronger than steel, and it's much stronger than anything else that's ever been made.
The mechanical climbers, or elevator cars, would be powered by electricity beamed up from the Earth station by laser. The energy efficiency of using these mechanical means to travel to space, as opposed to rocket power, could make the space shuttle a thing of the past.
Today, the shuttle can launch about 20 tons into space, about the same as a large truck. The space elevator, the first one, the small one, we can launch about 13 tons, and that can go 22,000 miles up, or it can take it further and launch it off the end to Moon or Mars. So we're talking about a system that can take a lot more cargo, and the elevator can be expanded to 20 tons, 50 tons, 100 tons, and take it up on a daily basis.
Full program confirmed.
Though NASA remains committed to using rockets to escape Earth's gravity, they are encouraging development of the space elevator with ongoing Centennial Challenge contests.
There are two competitions. One is a climber challenge, where you build a climber, it has to use beamed power, no connections, and it has to ascend a ribbon